Welcome to a new episode.
Hey, it's Chris Burnley here, and you're listening to the Copper Connection podcast. The podcast where we turn textbook and technical qualifications into real-world stories from the tools. Today we're talking about a word that gets thrown around a lot in construction and plumbing: sustainability. Now, before you switch off and thinking that's just a college buzzword stuff, stick with me, because sustainability isn't just about saving polar bears and planting trees. It's about the jobs you'll be working on, the regulations you'll need to follow, and the way you design, plan and install systems for the rest of your career. In fact, around 45% of the UK's carbon emissions comes from construction activities, and 72% of domestic emissions are from one thing we deal with all the time: space and hot water heating. So if you're a plumber, a building service engineer, or a training for your T-level in building service engineering, you're not just doing pipes and plan. You're on the front line of climate change and sustainable construction. So in this episode, we're going to be breaking down what sustainability really means in construction and building services, how it affects design, planning and work on site, some of the big frameworks and standards you'll hear about in the industry like BREEAM, LEED, WELL and PASS 2035 and 2038, and how retrofit needs opening up a massive amount of work for tradespeople like you. All in simple, no-nonsense language with examples you'll actually recognise from sight. So, let's jump straight into it. So let's start with the basics. Sustainability is often described as meeting the needs of the present without compromising the ability of the future generations to meet their own needs. In construction, that boils down to a simple idea: we don't have to stop building, we just have to do it right. Think of this: if you were fitting a new heating system in a house and you're knowingly sizing the boiler badly, ignored installation and used the cheapest materials that would fail in a few years, you might get paid today, but you're leaving a nightmare for the future you or for some other poor apprentice down the line. Sustainability construction is the opposite of that mindset. It means using renewable and recyclable materials wherever possible, reducing energy consumption in the building, cutting down on waste and pollution, and protecting the natural environment by air, water, soil, landscape, and even heritage buildings. Here's a stat that really hits home: 32% of landfill waste comes from construction and demolition, and around 13% of products delivered to site go straight into landfill unused. So over 1 in 10 materials that hit site never even get used. Imagine ordering 10 pipe fittings and chucking one straight in the skip every time. Sounds ridiculous, right? But that's what's happening at scale across the industry. Sustainable construction is about breaking that cycle. And for someone going into plumbing or building services, you're in a key position, because the systems you're installing can massively reduce a building's energy usage and its impact on the environment. Let's zoom out for a second and look at the natural environment we build in. When we're talking about sustainability in construction, we're not just talking about the building itself. We're talking about everything around it. So air quality, soil quality, landscape and heritage, and natural drainage and water resources. So now, let's look at air quality. Good air quality is vital, not just for people, but for plants, crops and wildlife. Construction activities can generate dust, fumes from machineries and emissions from materials. If you have ever been on site when cutting, grinding and diesel plant are going non-stop, you'll know what that feels like in your lungs. As future tradespeople, you'll be expected to use dust suppression where needed, follow rules around plant emissions, and think about ventilation, not just inside the building, but how your work affects the wider environment. Soil quality. Good soil supports food production, stores carbon and water, and gives us a sustainable base for foundations. If this soil is contaminated from spills, chemicals, or previous industrial use, it makes foundations more complex and expensive and can damage ecosystems. So sustainable construction means avoiding contamination, storing and reusing topsoil properly, and respecting what's already there on site. Let's take a look at landscape and heritage. In the UK especially, we build around heritage. Old streets, castles, building historical parks. You can't just rock up to a listed building and start drilling through a 200-year-old stone wall to run your pipework. Renovation of heritage buildings is heavily controlled, and rightly so. Sustainability here means working with the character of the building, retrofitting carefully and preserving the story of that place, not wiping it clean. Now let's look at natural drainage and water. Streams, rivers and lakes don't just look good on a postcard, they're natural drainage systems and ecosystems. Construction affects how water runs off roofs and hard surfaces, the risk of flooding and the quality of the water itself. So sustainable design might involve sustainable drainage systems, otherwise known as SUDs, avoiding pollution of watercourses and using water more efficiently inside the building. As building services engineers or plumbers, you'll see this in things like low flush fittings, rainwater harvesting, grey water systems and carefully routing of drainage to protect the environment. So that's the big picture. Let's bring it back into the project lifecycle you'll actually be working in. Think of a construction project as having a life cycle. We have the initiation, then the planning, then the implementation and execution, then monitoring, and then the closing. Sustainability runs through all of these stages, but the three are especially important for you will be design, planning, and production. Design, where most of the big decisions happen. During the design phase, sustainability should be a key priority. This is where architects, building services designers and clients make decisions about how the building will perform, what materials and systems will be used, and how energy efficient it will be. For example, will the building use heat pumps instead of gas boilers? Is there solar PV on the roof? Is it designed to minimise heat loss, insulation and air tightness? If you're thinking of a project like an exam, design is the revision stage. If you get these things right here, the actual exam, the build, goes so much smoother. Architects and designers can recommend sustainable materials, suggest renewable energy systems, and design buildings that need less energy in the first place. Planning, making sure it's legal, practical, and resourced. At the planning stage, the focus is on making sure the project meets legislation and local sustainability requirements, liaising with local authorities and ensuring there's enough resource, tools and equipment to get the job done. If you've ever turned up on site and half of the kit is missing, you'll know that kills productivity. From a sustainability angle, poor planning can lead to extra deliveries, wasted materials, and rushed decisions that ignore environmental best practices. Good planning includes thinking about waste management, planning logistics to cut unnecessary trips, and check that products and materials meet sustainable standards. And then we have production, putting sustainability into action on site. Then we hit the production phase, where you come in, boots on ground, and this is where site management plans are put into action, waste is segregated, recycled and disposed of correctly, and the actual installation work reflects the sustainable goals of the project. Remember that stat, 13% of all products delivered to site go straight into landfill without even being used. On a sustainable site, that's exactly what you're trying to avoid. So you might see separate skips for different waste streams, clear instructions on recycled materials, and rules about how to handle hazardous waste properly. And it's not just about the waste. The whole sector is increasingly focused on reducing fossil fuel usage, cutting operational energy, and meeting net zero targets. That brings us neatly to energy consumption. So energy is where building services engineering really earn its stripes. As we said earlier, 72% of domestic emissions come from space and hot water heating. So the way you design and install the system matters a lot. Construction and buildings use a huge amount of energy, both in construction and operation. The sector is now focused on reducing reliance on fossil fuels, improving installation and efficiency, using controls and smart systems to avoid wasted energy. You will see more condensed boilers, where still allowed, heat pumps air source or ground source, and mechanical ventilation and heat recovery, or MVHR, and more efficient hot water systems and controls. The UK government has various policies and incentives to encourage low carbon buildings. On projects, you might come across solar PV, generating electricity from sunlight, micro wind, small wind turbines for certain sites, and ground source heat pumps, using the ground's stable temperature to heat buildings. As an apprentice or student, you don't need to be an expert of all of this yet, but you do need to know they're part of your future workload. Construction uses a vast amount of physical resources: concrete, steel, plastics, timber, insulation, pipework, ducting, you name it, we use it. Sustainability construction aims to use renewable and recyclable materials where possible, choosing materials with low embodied energy, meaning it doesn't take a lot of energy to produce them. Think about the whole life cycle of a building, not just the first installation. On site, that might look like using certified sustainable timber, choosing products that you can recycle at the end of the life, and segregating waste so it can be recycled. Remember, waste that's properly sorted on site is more likely to be reused or recycled, not just buried in landfill. Now, let's look at some of the big names and standards you will hear as we move through your career. You might have heard tutors or site managers throw around acronyms like BREEAM, LEED or WELL. Let's decode them simply. BREEAM is one of the world's leading sustainability assessment methods for buildings and infrastructure. It looks at environmental, social and economic performance of a building and gives it a rating through an independent certification process. Why does this matter to you? Because BREEAM-rated developments are designed to reduce environmental impact, aim to cut operational costs, improve health and well-being for occupants, and can make assets more attractive to sell or rent. From your viewpoint on site, it might mean stricter rules on waste and recycling, careful choice of materials and products, and a higher expectation around energy performance and the systems you install. Then we have LEED, Leadership in Energy and Environmental Design, is another green building certification system used globally. Projects earn points in different categories like energy, water, materials, indoor environment, and the total score gives them a certification level. For you, LEED is important because it shapes the specifications you work with, drives demand for high efficiency systems and materials, and adds another layer of quality and sustainable requirements on site. Then we have Trader, which is a timber research and development association, which is all about timber. It's an organisation that helps the industry use timber correctly and sustainably. Why should a future plumber or building service engineer care? Because timber is a key sustainable material in construction. You might be working on timber frame buildings where moisture, service routes and fixings all matter. And understanding how structure, materials and services interact make you a better, more employable tradesperson. The WELL building standard is all about people, health and well-being inside buildings. It looks at things like air quality, water quality, light, thermal comfort, sound, movement, nourishment, materials, and mind and community. For building services, this is huge. The systems you install will affect how clean the air is, how comfortable the temperature feels, how noisy plant is, and how well lit and pleasant space areas are. How well lit and pleasant spaces are. When you get these things right, buildings don't just tick boxes, they become better places to live, learn and work. Now let's have a look at retrofitting and pass 2035 and 2038. Now here's one of the biggest growth areas for future career, which is retrofitting. Retrofitting means upgrading existing buildings to improve their energy efficiency instead of knocking them down and starting again. It's super powerful because it tackles climate change by cutting energy use. It helps reduce fuel poverty by lowering bills and avoids the massive carbon cost of demolishing and rebuilding. There's two key standards here, and as I've mentioned, one is PAS 2035 or 2030 for domestic retrofit properties for dwellings. And then we have PAS 2038 for non-domestic buildings, which are all other types of buildings. They set out how to assess buildings properly, design and specify energy efficient measures, and implement and monitor retrofit projects. So what does this mean for you? It means there's a huge amount of work now coming up in upgrading heating and hot water systems, improving controls, integrating renewables, improving installation and air tightness along with other trades, and making older buildings fit for the future. If you're thinking about a long-term career path, getting your head around retrofit and these standards can make you a go-to person within your company. So let's bring this all together. Sustainability in construction isn't just some topic bolted onto your course. It is built into the design of the buildings you'll be working on, the planning of every project you'll be on, the production and installation of the work you'll be doing day in, day out, and the standards and frameworks that shape the industry with BREEAM, LEED, WELL, and PAS 2035 and 2038. As a plumbing or building services apprentice, you're not just learning how to run pipes or set up plants. You're learning how to protect air, water and soil, cut energy use and carbon emissions, retrofit and upgrade the buildings we already have, and help create healthy, efficient, future-proof spaces. Next time you're on site or in a workshop at college, take a second to look around at what you're doing and ask, if this building is still here in 50 years, will the work I'm doing today still make sense for the people using it and for the planet? If the answer is yes, that's sustainability in action. If you've found this episode useful and you want more straight talking, trade focused breakdowns of stuff that actually matters in your qualifications and on site, follow and subscribe to the Copper Connection podcast. We've got more episodes coming up on real-world retrofit projects, low-carbon heating systems, study tips for your T-level and other technical qualifications, and an honest conversation with people actually working in the trades right now. I've been Chris Bailey. This has been the Copper Connection podcast. Thanks for listening, and I will catch you on the next episode.
We'll be back next week. In the meantime, please subscribe and thanks for listening.